This is Project Team A5, and our project is reducing 30-day emergency department readmissions for a large healthcare organization in the Northwest. We'll begin with team introductions.
Hi all, this is Malika Valram.
Hi, I'm Richa Rajpal Das.
Hi, I'm Yashika Jain.
Hi, I am Sai Sindhura Pusarla.
Hello, my name is Michael Turek. For our agenda, we'll begin with the project overview. We'll go over the project in phases 1 through 4 as completed through the program. We'll have our first live demonstration of our Power BI dashboard. We'll have 2 demonstrations of our model deployed and in action, and we'll conclude with suggestions and next steps. For our problem statement, our goal is to reduce 30-day emergency department readmissions for a large healthcare organization in the Northwest. Our method: utilize the electronic health record database, analyze the current emergency department admissions data, and design a model for predicting 30-day emergency department readmission occurrences. So we did experience a project scope shift that shifted from an ROI analysis of a department to a key metric of interest to an organization, which is 30-day readmissions to an emergency department facility. And we keyed in by phase 3 on a very specific population, which is seniors having Medicare as a payer type, and looking at ailments in accordance to the Accountable Care Organization ACO 38 measure, some of the examples that we see here on the left. I do want to point out that the client organization was not interested in these specific ailments, but rather the count of ailments associated with the patient. Phase 1 was discover a plan in which we performed business discovery. And in this, we completed a number of industry and market analyses as well as company analysis. This included Porter's 5 forces, best practices, current digital solutions being utilized in the healthcare industry, company-wide SWOT analysis, business model canvas, and also diagramming and analyzing the workflow and the business process of the organization. Key insights from phase 1 were that 2018 costs for payment shortfalls in Medicaid, fee-for-service, managed care plans, and other subsidized healthcare programs exceeded $200 million. 1 in 5 Medicare beneficiaries industry-wide is readmitted within 30 days at a cost of over $26 billion per year. And Premier found that among the 120 Medicare ACOs that it advises, about 30% of ED visits occurred for issues that could have been handled in primary care. Phase 2, plan analysis and design, is which we acquired data and began data discovery. About the data, our initial data set contained 800,000 rows of emergency department admissions from 2016 to 2019 and included 19 columns of various patient demographic, socio-demographic, facility, and patient outcome variables. In defining the target variable, we observed that there were 3 different admissions type, as explained here. And what we defined as our target variable was has revisit or visit leading to revisit. This is an admission having a subsequent admission within 30 days. We did draw 2 key data insights when we began our data exploration process. First, in regards to insurance payer type, the top 3 insurance payers for emergency department initial visits and revisits was 3 forms of Medicare. And also revisit percentage for the 61 to 80 age group was of keynote because it spiked at that point, as we see here in the graph over the orange bars. So we targeted in on this population and it reduced our data set to 92,000 rows for seniors having forms of Medicare. All other factors remain the same, except now we added count of chronic diseases associated with the ACO 38 measure. And now we'll go to our live demonstration, descriptive analytics using the Power BI dashboard.
Thanks, Michael. Here we have created a 2-page dynamic dashboard on Power BI. The first page gives us an overview of the emergency visits, and the second page gives us the socio-demographic factors shared by the healthcare organization. A disclaimer before we actually talk about the charts: the data labels, the revisit percentages, and the summary statistics have been masked to safeguard patient information. On the top left here, we have the volume of visits, and the revisit percentage from year 1 to year 2 has increased by approximately 1%. But from year 2 to 3, we notice that the revisit percentage is approximately the same. But from year 3 to 4, we can notice that it's dropped, but that's because we had the information only until August, so we can't be definitive about the results. At the bottom, we can see that our healthcare organization has 6 facilities. The volume of visits are highest for facility 1, but the revisit percentage is the highest for facility 3. On the top right, we can see that as the count of chronic diseases increases, the revisit percentage also increases. On the second page of social demographics, we have 4 charts: revisits by race, by patient language, marital status, and age. On the top left, we can see that the volume of visits are highest for race 1, but the revisit percentage is highest for race 7. On the top right, we can see that when the patient language is not English, the revisit percentage usually increases. On the bottom left, we can see that the revisit percentage is highest for the marital status 1. On the bottom right, we can see that as the age increases above 75, the revisit percentage is relatively higher. That's it about the dashboard. We also did a year-over-year trend analysis, and these are some of the key insights. From year 2 to 4, the revisit percentage is consistent, except a spike in the revisit of approximately 1% from year 1 to 2. For the variable facility, facilities 4 and 5 show a downward trend in revisit percentage, whereas facilities 1, 2, and 3 have an upward trend in the revisit percentage of approximately 1 to 2%. For the variable race 7 shows a significant upward trend of approximately 10% of the revisit percentage, and that's largely because of the males. Whereas race 3 females show a significant upward trend of approximately 5% of the revisit percentage. For the variable marital status 2 and 3 show a significantly upward revisit percentage. So that's about the descriptive analytics. Now Sindhura will talk about the phase 3 modeling. Thank you.
Thank you, Richa, for explaining the dashboard. In phase 3, our team developed a machine learning model that predicts the probability of a visit turning into a revisit. It is a classification model as we are predicting the probability of a visit turning into a revisit. The target variable is either 0 or 1. In order to implement this classification model, we have tried out different classifiers such as logistic regression, naive Bayes, neural network, random forest, and random forest proved to be the best classifier for the data set with an AUC of 0.77. AUC is the metric that we are considering here to choose between the different classifiers. AUC denotes the capacity of the model to clearly distinguish between 0 and 1 classes. So the AUC generally ranges between 0 and 1, and we have an AUC of 0.77. Random forest, the selected classifier is nothing but set of sample different decision trees, and one such sample tree is displayed here. And the sample rules for such decision trees can be like when the patient language is not English, the probability of a visit turning into a revisit is high. Also, when the number of chronic diseases increase, the probability of that visit turning into a revisit is high. We obtained the variable importance plot from the random forest. Our client provided us different variables, but these variables proved to be significant. So with the religion being on top, followed by age, facility, marital status, count of chronic diseases. How well does our model perform? Model is 77% accurate. Out of 9,232 visits, which led to revisits, our model identified 5,959 visits. This means that our model was able to correctly identify 64% of the potential visits that led to revisit. If a client pays attention to the visits that are identified by the model, then the readmission index could be reduced. This readmission index is a metric of interest for all the healthcare organizations. Thank you. I would now pass it over to Yashika.
Thank you, Sindhu, for explaining about the model. Now let's look into how much this model can save us in terms of dollars. According to Consumer Health Ratings, an average cost per year visit in the US is around $830. And with the enhanced treatment and the focused measures, if the hospital is able to reduce even 50% of those identified visits, they could save millions of dollars. Now, those 50% of the visits is actually equivalent to 33% of the total revisits. And hospital is penalized for excess revisits from hospital readmission reduction program. And through this reduction in the revisits, it actually decreases the total revisit percentages by 4%. And hence, it can lead to reduction in the penalties or even totally avoiding those penalties. There would be an increase in patient satisfaction because of the enhanced measures and the focused treatment which the patients are getting. Again, there would be millions of dollars of savings in community health expenditure. Now let's see how our model would be deployed and how it would work. Now, these are the predictor variables which we can see, which we have been talking about the whole time. And our model requires the input in these formats. Once we click on request and response, we can see there would be a scored label and scored probabilities populated for that patient and for that particular details which we have entered. A scored label of 1 means that there would be a revisit and the probability is 0.875, and hence there's an 87% chance that the patient would come back or have a revisit in within next 30 days. This is how a deployment for the model would look like. Now I would hand over to Monica for the cognitive implementation of the model. Thank you.
Thank you, Yashika. Now that we have seen how our model performs, let's see the feasible solution that we have come up with that can be used by the clinical staff and doctors in their day-to-day activities. And that solution of ours is a mobile application. Here we have used a technology called Power Apps to build our application. Power Apps because it allows its users to develop applications very quickly with its predefined templates. And below is an image of the structure of our application that we have built. Now, let me walk you through the proof of concept that we have created as a part of our application. Now here on the first look at the application, we have a list of all our patients. The patient names here are masked and given a certain dummy name. To know more about each patient, we can navigate to the next page where we have detailed information of each patient. Now, if a clinical staff wants to notify the primary care doctor of a particular patient about the factors that are contributing to the readmission of the patient, it can be done by an email notification feature that we have, and a message can be sent to the doctor in advance, and the care can be provided to that patient accordingly. So, how can this proof of concept of ours be used to build several top-notch applications? Is that in a scenario like COVID-19, like we have now, the admitted patients' factors can be captured and compared against the patients in our health record, and those that are prone to the virus can be identified, and awareness can be provided to the patients, and thus reducing the outbreak. So why have we thought of mobile apps as a solution for our organization is that it aligns to the business purpose in a sense that it satisfies the basic necessity of patient monitoring. The apps, as they are easier to build, are also easy to use by the clinical staff and doctors. They are multifaceted in a sense that it can be applied across other domains such as sales and marketing apart from healthcare. This can be supported by the array of advantages that mobile apps have, that it is proven to have effective communication between patients, providers, and medical staff, and it is termed as AI revolution in emergency care in recent times. The doctors can also access and capture the patient images and reports from anywhere in the world very securely. The e-prescription have been a landmark change, and they are anticipated to reduce readmissions if implemented efficiently, not only from the patient's perspective, but also the organization as a whole can benefit by reduction in costs and workflow management. Thank you, and I now would like to hand it over to Michael to continue.
Thank you, Malika. For suggestions for improvement, we would first recommend addressing data completeness, increase data entry by medical staff during patient admission, and conducting additional research. This would be looking at primary diagnosis codes on the index visits and the revisits, looking at the causes of readmissions within 30 days, conducting text mining of discharge instructions and patients' adherence to the instructions, and taking a look at seasonality of the data to understand weekly, monthly, yearly, and year-on-year performance, and continue model refinement using sample sociodemographic data. In terms of next steps, we would recommend implementing the suggestions to refine the model, integrating the machine learning model and the algorithm into the electronic health record system, and operationalizing the model results. This could be within a certain probability threshold, immediately establishing an appointment with the patient with a primary care physician, or utilizing virtual healthcare services. Again, here's our team. Thank you very much, and we invite you to attend our poster session.